Hi, my name is Chris Snyder. I'm in Ryan Euler's Fundamentals of Physics class at 1 p.m. Today I'm going to be showing you a little experiment that has to do with gravity. So, quick introduction about gravity. Gravity is a constant force that affects all objects in the world. As you can do a little experiment by yourself. Actually, if you just jump straight up in the air, you come back down, and the only reason why you come back down is because of gravity. Gravity affects every object in the world, no matter shape, size, anything. And especially in this class, only in this class, that gravity is actually a falling constant speed of 10 meters per second squared. Now, that's actually 9.8 something, but it's easier to do 10. But so the way you can tell that gravity is affecting you is you can step on a scale. And the reason why that scale shows that weight is because that's how much is pulling down towards the ground. Also, if you throw a hammer off the top of a building, that would fall pretty fast. But if you threw a feather, that would kind of float down to the ground pretty gradually. Now, the only reason why these two objects don't hit the ground at the same time is because of air resistance. Air resistance plays a really big part in why two objects don't hit the ground at the same time. If you were to use a vacuum and you dropped a lead ball and a feather, those two objects would both hit the ground at the same time because of gravity. And gravity, like I said, is a falling constant speed that doesn't change. No matter what the parameters are of the experiment, it's always going to be a flat 10 meters per second squared. So, another way you can think of it is if you let's say you drop a 1 kilogram ball and a 10 kilogram ball. Now, let's say that for those people who think that gravity doesn't affect the way things fall, let's say that the 1 kilogram ball falls slower than the 10 kilogram ball because it is less massive. So, okay, alright, so it falls and they hit the ground at different times. If you tie the two balls together, is the two balls going to fall faster because they're now 11 kilograms? Or will the two balls fall slower because the 1 kilogram ball holds it up in the air longer? No, that doesn't make sense. So, honestly, everything in the Earth falls at the same rate of speed. But I can show you this. I can prove this to you. I promise you it's true. I have this book. Nice book. Very light, airy. Not a hardcover book. Very small. And I also have this book. Much more massive. Much heavier. Hardcover. Pretty big, as you can see. Bigger than my head. This book, in comparison. There you go. 2 books. And what I'm going to do is I'm just going to drop these 2 books. And the good thing about these 2 books is that they actually are pretty much the same shape. So the air resistance is basically the same. So I'm going to drop these 2 books now. And as you should see, they will both fall at the same rate of speed. So, there you go. These 2 books hit the ground at the same time because gravity always falls, or always takes objects back to the Earth at 10 meters per second squared. So, in conclusion, gravity is a constant speed that only has an effect when air resistance come into play, and that's pretty much the experiment. Like I said, I'm Chris Snyder, Ryan Euler's Fundamentals of Physics class at 1 p.m. Thank you, and I hope you enjoyed watching this video. So, goodbye.